We will be factoring trinomials with a leading coefficient other than 1. And so what this might look like is having our leading coefficient here is 3. And remember, it's important to keep in mind that our constant is 8, our middle term is 14x. And the way that a trinomial with a leading coefficient other than 1 is a little bit different from trinomials whose leading coefficient is 1 is the way we're going to solve them. So we need to begin, and this is a little bit different step, by multiplying that leading coefficient of 3 by the constant of 8. In doing so, we get 24. And notice 3 is positive, 8 is positive, so I'm multiplying to a positive 24. And now we want to list all the pairs of numbers that multiply to that positive 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. With those pairs of numbers we just found, we now are looking for which pairs of factors add up to that middle term of 14x. And we see that 2 and 12 would add up to 14x. So now we want to rewrite our trinomial, 3x squared, using that middle term as the sum of the two factors. So 14x will now be rewritten as adding 2x and adding 12x plus 8. Note that 2x plus 12x equals 14x. So right now I have not changed the problem. So this rewritten expression, 3x squared plus 12x plus 2x plus 8. In the previous slide, I discussed and I wrote it as 2x plus 12x. It doesn't matter which way you write those two middle terms. And again, we have not changed anything from the original trinomial. But now I'm going to look to factor by grouping. Note that I have 4 terms, and when I see 4 terms, I automatically am going to think, can I factor by grouping? Well, let's check it out. 3x squared plus 12x plus 2x plus 8. I will group my first 2 terms and my last 2 terms. Taking out my greatest common factor, I have 3x. I am left with x plus 4. I'm going to take out a 2, and I'm left with x plus 4. And now we know with our factor by grouping method, we can rewrite that as 3x plus 2 times x plus 4. And by foiling or distributing, we can quick check this. 3x squared plus 12x plus 2x plus 8 does indeed 3x squared plus 4x plus 8 our original problem. And so the key steps here were multiplying our leading coefficient by our constant, looking for those pairs of numbers that add up to the middle term, and rewriting it so we can factor by grouping. Let's look at another example. And in this example, I still see that my leading coefficient is 6. But if I look carefully, I see that I have an x cubed. And actually looking even more carefully, I see that I have a factor of 3 in all of this. So I'm going to start by factoring out the greatest common factor. The greatest common factor is 3x in this instant. When factoring that out, I'm left with 2x squared plus x minus 21. And now I want to think, can I factor this even farther? Well, let's check it out using factoring with a leading coefficient not equal to 1. We have a 2 and a negative 21. And multiplying those two numbers, we get negative 42. And so now we want to rewrite this with factor by grouping. We're going to look for the pairs of numbers that multiply to negative 42, but add to a positive 1. Well, I know that 7 and 6 multiply to 42, and a positive 7 and a negative 6 add to 1. I'm going to put some big brackets around this because I don't want to forget I have a 3x that I had factored out through greatest common factoring. And so now I'm going to factor by grouping. 2x squared plus 7x, those two are going to be grouped, plus a negative 6x minus 21. In factor by grouping, I'm going to take, all I can really take out of this is an x. So an x, and I'm left with 2x plus 7. And in my next set of terms, I'm going to take out a negative 3. This will leave me with 2x plus 7. And now I see that one of my factors is x minus 3. And my second factor is 2x plus 7. And you have to continue bringing down that greatest common factor of 3x. So the fully factored form of this is 3x times x minus 3 times 2x plus 7.